Let's say that we had a fraction, and in the numerator there is one term and denominator one term. These are all being multiplied, and the fraction in and of itself is being divided. In order to do this, you would do it in steps. So 125 divided by 25 is 5 over 1. I'm not going to put the 1 in the bottom. We'll just move on. And I want to treat this part, x to the third over x to the fourth, as a separate problem. And the rule when we are dividing exponents is that we subtract them. So this would be the 3 minus 4, which gives me minus 1. And x to the minus 1, well, that's 1 over x, so I'm just going to put the x down here. I don't need to put an exponent, but it is a 1. The next part is y to the fifth in the numerator and y squared in the denominator. Well, again, we're going to subtract when we're dividing exponents, so this is the 5 minus 2, which is y to the third. This is a positive exponent, so this would go in the numerator. So this here is the answer, 5y cubed divided by x. So in this problem here, I have two terms being multiplied by each other. And we notice that we have negatives, we have a coefficient, we have two different variables. So what we do is we treat them as if they're different problems. And I would recommend that you look at this and you do number times number, letter times letter, the next letter times letter if there is one, and then do sign times sign. Don't try to do everything in your head all at once. So I do number times number, I write the answer. Then I'm going to do letter times letter. So x to the fifth times x to the fifth. I add the exponents, that's x to the 10th. And then I have y, there's a 1 here, even though it's not written. So I have y to the first times y to the third, that's y to the fourth. And then finally, I have a negative times a negative, which is a positive. When the leading coefficient is positive, you don't actually have to write that. And then that is the final answer. Moving on with an additional example. I strongly suggest that you watch until the end of the video because you'll get a full sense of security if you just watch a few, and we'll continue on. So when I'm going to do the 6/9 first, they're both divisible by 3. So 3 goes into 6 2 times and into 9 3 times. That can't be simplified any further, so I'll put the 2 and the 3 over here. Now when I'm doing x to the 6th divided by x to the 8th, I subtract the exponent, so that would be x to the 6 minus 8, which gives me x to the minus 2. Since this is a negative exponent, I would then put this in the denominator as x squared. And then the final one, I have y fourth minus y to the third. That's y 4 minus 3, which is y to the first power. So that would stay in the numerator. I don't have to put the 1 there. And this is my final answer. This problem is a power raised to a power. You have to treat this as if it's 3 individual problems. You're going to raise each of these things inside to the 4th power. Well, I can write 6 to the 4th power, but that's 1,296. No, I didn't just do that in my head. And then I have x to the 4th raised to the 4th. We multiply when it's powers, a power of a power. So this would be x to the 16th. And then y, and it'd be 3 times 4 is to the 12th. And this is the final answer. This problem kicks up the difficulty quite a bit, but if you recognize that this is just squaring a binomial, we would use FOIL for the long method, where you would actually write it out 5x to the third plus y squared times itself. Now, as we continue, you're going to do the first terms, outer terms, inner terms, last terms. So I'll just do first terms are 25, and x to the third times x to the third is x to the 6th, plus, now I'm going to have 5x squared, 5x to the third power y squared, And those are the outer terms. That's the O. And then when I do the inner term, it's going to be the exact same thing. So it's 5x3 y squared. And then finally, we have the last terms, y squared times y squared is y to the fourth. And then I want to simplify by adding like terms. So I have 25 x to the sixth plus 10 x3 y squared plus y to the fourth. And this is our final answer. For this problem, I'm going to treat each internal piece as an individual problem. So I'm going to raise -2 to the fourth power. I'm going to raise x to the third to the fourth power, and finally y squared to the fourth power. So 2 to the fourth power is 16. And when I have an even exponent, so this would be 1 times 4, so it would be to the fourth power. This would actually become positive. If it's an odd number for the exponent, then it's going to be negative. So then I have x to the third raised to the fourth power is x to the 12th. I multiply them when I'm raising a power to a power. And again, for y squared raised to the fourth power is y to the 8th. And this is the final answer. Again, I've had this in another video, but just so that you understand, if I have -1 raised to some odd number over here, or -1 raised to an even number, this is an 80. So I'm not going to actually multiply -1 times itself 77 times. I just look at to see if this is an odd or even number. If it's odd, then this is -1. And if it's an even number, this is a +1. This question has appeared on the SAT and ACT college entrance exams. Don't fall for the trick. It's not asking you to actually do that, and you don't have to enter it into a calculator, although if you want to do it when you're not taking the test, and you'll see that this is true. Okay, so here again, we have a binomial times itself. So we have 5x squared minus y and 5x squared minus y. Then when we multiply, we get 25x to the fourth minus 5x squared y minus 5x squared y minus y squared. And I combine like terms. And this is the final answer. In this last example, I'm going to raise the 4, the x to the fifth, and the y squared all to the third power. So first, 4 to the third power is 64. And since 1 times 3 is an odd exponent, it's going to be negative. Then I have x to the fifth to the third is x to the 15th. And then I have y squared to the third power is y to the 6th. So a power raised to a power you multiply. And we're done.